Hi, my name is Dr. Helen Lever, and in this short tutorial I want to cover the topic of ripples and how they create cross-stratification. Ripples are bed forms. That means that they are formed on the sediment surface while some kind of process is happening to that sediment. Ripples are peculiar in that they have an asymmetric shape, so they are gentler on one side and steeper on the other side, and they are formed in unidirectional aqueous currents. They are also only about 5 centimetres high, so that is another distinguishing criteria. Ripples have a number of words that are associated with this shape, which we need to define before we can talk about ripples further. The top of the ripple is called the crest. The base or the trough shape as the ripple bends up into the next ripple is called the trough. The steep side is called the lee side, and the gentle side is called the stoss side. So that's how the ripple basically is shaped. So how are ripples created? Ripples are created during the transport of sediment along the sediment-water interface. What happens is the water transports the sand grains up the back side of the ripple. They accumulate in a wee space at the crest of the ripple, and then they cascade down the lee side, creating a new face of the ripple itself. The ripple then actually migrates downstream because this new face is pushing the ripple downstreamwards, and so you get several new faces, and these are known as faucets. Each new position of faucets means that the back side of the ripple must also migrate downstream. So our successive ripples are migrating downstreamwards in steps caused by these avalanching of sand grains onto the ripple face, the ripple lee face. So why do the sand grains act like this? They act like this because the flow is changing as it goes across the ripple. Our unidirectional flow is pushing sand up the back of the ripple, but when it hits this crest point, it splits into a flow that is continuing onwards and a sort of backflow region which is circulating around. And this zone right in the middle here, where the sand grains accumulate, is a dead zone or very, very gentle energy zone. And that's why sand accumulates there, until it gets too much and cascades down the front to create one of those faucets. Sand is also actually being carried along in the flow and will also rain out onto that front by deposition from suspension and will be deposited as part of these faucet beds. That means our faucets are likely to be composed of quite coarse sand grains on the bottom layer and quite fine sand grains towards the top of each layer. So how is this deposited and how does it turn into sedimentary structures? When the ripple migrates, as you can see by this diagram here, we are in fact actually eroding part of the ripple, and if it just continues without any deposition, then each successive stoss side of erosion is removing previous parts of the ripple there, and you'll just end up removing all of that and just continuing to have a succession of ripples being deposited, being transported. What we actually want to have preservation of the ripples is we want to have deposition. And in order to have deposition of sediment, we need to have enough space for the sediment to be deposited in, that's accommodation space, and enough sediment supply for there to be sediment to be deposited. However, if those two conditions are satisfied, then we will in fact deposit ripples as they're being transported along in our flow, and that way we'll actually preserve some of these faucet beds. So how that actually works is where we start with our ripple and we're depositing faucets in the front, and each time we deposit a faucet we're moving the crest up to represent deposition and of course along to represent the migration of the ripple. So if we continue to do that so that each successive crest is just a little bit up and a little bit further along, then what we end up creating is a succession of preserved faucets. And this is what we see in the rock record. So in the rock record, we often see these erosion surfaces which represent this erosion on the stoss surface, and these inclined faucet beds in between the erosion surfaces, and that is known as cross-lamination. Okay. Now ripples can have straight crests, which would create these straight erosion surfaces, or you could also have ripples which have a curved crest. So the ripple shape like that, but the actual crest is a sort of curved shape. And you would then see that in 3 dimensions. If you have curved crests, then these erosion surfaces will be curved rather than being straight, and the actual sedimentary structure that you will get will also be curved and intersecting curved cross laminations like this. And this is known as trough cross-lamination. And in order to distinguish it, we often call this with the straight sets tabular or sometimes planar cross-lamination. So that distinguishes the 2 different shapes. If we have a lot of deposition and a lot of accumulation, therefore, then we can in fact sometimes preserve the entire ripple crest shape. So if we do that, then each successive layer is in fact preserved in its entirety, so the ripple shape is never lost. And this is known as climbing ripple cross-lamination. And that means that the entire crest, and this only happens in very rare examples where you have a lot of deposition and a lot of accommodation space and sediment supply to create that. Okay, so the last thing to say in this tutorial is that everything that I've said here about the shape and the structures being produced totally applies also to mega ripples. Now mega ripples are a larger scale structure, so these are 5 centimetres high, these ripples. Mega ripples are more than 10 centimetres high, and they go up to several metres in height if they have a sufficient depth of water in which to be developed. They are, however, basically exactly the same shape as a ripple, and they form the same variety of structures just on a larger scale than you see here with ripples. So a ripple set, that's the name for this section here, is going to be less than 5 centimetres high, and a mega ripple set will be larger than that, 10 centimetres, 20 centimetres, a metre or more. I hope that helps you to understand how ripples and mega ripples migrate to create sedimentary structures, cross-bedding in the mega ripples case and cross-lamination in the ripples case.